So in this series, you're going to look at electricity calculations that have to do with it. So you're going to start from the easiest and then build up in that order. Now there are some few things I'm supposed to bring across to you. So we have current, we have resistance, and we have potential difference. Is also sometimes used mentioned as voltage. So current has a symbol of capital I, resistance capital R, potential difference of voltage has a symbol of capital V. Now, current is measured with an ammeter, resistance is measured with an ohmmeter, and potential difference is measured with a voltmeter. Potential difference equals current times resistance. And we can also have power in there. Power equals current times potential difference. Current of 5 ampere, I equals 5 ampere close to a resistor of 2 ohms. Calculate the voltage or potential difference. V equals IR. So our current is 5 multiplied by our resistance, which is 2. We're going to have 10 volts. The unit for current is ampere. The unit for resistance is ohms. The unit for potential difference is volts. Now you can pause the video and then try this question. So a 12-volt battery is connected to a resistor. If the current is 3 ampere, find the resistance. So 12-volt battery. So we have 12 volts. It's connected to a resistor, and we're not given. If the current is 3 ampere, find the resistance. So V equals IR. You're supposed to find the resistance. So divide both sides by I over I. So I cancels I. So we are going to have resistance equals 12 volts over 3 ampere. 3 here 1, 3 here 4. So we're going to have 4 ohms. A 100-watt bulb operates on a 220 volt supply. Calculate the current flowing through it. So I give you another formula. Power equals current times voltage. Our power over here is 100 watts equals potential difference is 220 multiplied by the current. So you have to divide both sides by 220 over 220. So 100 divided by 220. So our current is going to be 0.454 ampere. If a resistor dissipates 50 watts of power when connected to a 10 volt supply, find the resistance. So power equals current times voltage. So the power here is 50 watts equals now looking at this formula, we'll not be able to work it out, but we can bring the two formulas together and then do something. V equals IR and then P equals IV. Now what if we make current the subject? So over R over R. So R cancels R. So we have I equals V over R. So this simply means anywhere we see I, we can put V over R there. So P equals, now this is our I, which is our current. So V over R times V. So P equals V squared over R. So P equals V squared on R. So we are supposed to find resistance. Now, if you follow my series, I told you that anytime you want to make a denominator a subject and then you have a variable that is equal to, let's say, a fraction, you just exchange the position. So R equals V squared on P. So we have V to be 10. So that's our voltage, 10 squared over the power 50 watts. So 10 squared is 100 over 50. So 50 here 1, 50 here 2. So our answer is 2. And what's the unit for resistance? 2 ohms. That is it. Now pause the video and then try this. A current of 2 ampere. So I have a current to be 2 ampere flows through a 10 ohm resistor. Our resistance will be 10 ohms. For time 3 minutes. Calculate the energy dissipated. Now throughout you realize that we've not dealt with energy, but there's a way around it. That is why I told you in this series everything is connected, so you need to follow step by step, one video after the other. Now let me break it down. As I already mentioned, I said that if you are asked to find something that is not in the formulas, you need to use what you have to find something that is connected to what you have been asked to find. Now what is energy connected to? Remember, energy is connected to power. Power equals work done. Now the work here is synonymous to energy, so we can just say energy over time taken. So it means that if we don't have our power, there is no way we can find our energy. So we first need to work our way around to find the power. After we get the power, we already have the time, so we can find our energy or work. Okay, so we already mentioned that P equals V squared on R, and we also have P equals IV. Now remember this formula, V equals IR. And what do we need here? We need to be able to connect our current and resistance. We can find our potential difference of the voltage. Thus, you connect it to this formula. Our current is 2 ampere. So V equals 2 multiplied by our resistance is 10. So our potential difference of voltage is 20 volts. So right from here, we can fix it into this formula. So P equals V is 20 squared on R. What's our resistance? Our resistance is 10, and power is going to be 400 over 10. So our power is going to be what? 40 watts. And if we have our 40 watts, we can work our way around. But take note, the time. Remember what I said about the time? We have to convert 3 minutes to seconds. Now, if 60 seconds make 1 minute, then how many seconds will give us 3 minutes? So 3 times 60. 3 times 60 is 180 seconds. So 180 seconds. So that's what we are going to work with. So we know our time to be 180 seconds and our power to be 40 watts. Time is 180 seconds. Our power is 40 watts. So we know power equals energy or work done over time taken. So 40 equals the energy over 180. So our energy dissipated is 40 times 180. 7,200. What's the unit for energy? Joules. A 9-volt battery is connected to two resistors, 3 ohms and 6 ohms in series. First, we are supposed to draw the circuit diagram. Find the total resistance and the current flowing through the circuit. So we should be able to draw. So a battery, a 9-volt battery. We have a battery here and our two resistors all connected in series. Then we have our 3 ohm resistor here and 6 ohm resistor also here. So we are first supposed to find the total resistance. Now, connection in series. RT equals, we are just supposed to add them. 3 ohms plus 6 ohms. We are going to get 9 ohms. So that's our total resistance. And we are supposed to find the current. V equals IR. Supposed to find the current flowing. So when you make I the subject, you're going to have I equals V over R. So we had 9 volts over resistance of also 9 ohms. So our current is going to be 1 ampere. I'll pause the video and then try this question. A 6 ohm resistor and 12 ohm resistor are connected in parallel to a 24 volts battery. Draw a circuit diagram for the setup. So I'll start with the resistors. Now this is also another symbol for resistor. Take note of that. This looks like a zigzag. Then 24 volts battery. So 6 ohm, 12 ohm. So 24 volts battery. So you are supposed to find the total resistance. Now, when it's connected in parallel, this is how you find the total resistance. 1 over RT. The RT represents total resistance over equals 1 over R1 plus 1 over R2. So R1 here is 6. So plus 1 over 12. So 1 over RT equals, so 1 over 6 plus 1 over 12. 1 over 4. Now, we are actually looking for RT, not 1 over RT. So whatever I do to the left hand side, do to the right hand side. So we can reciprocate both sides. So we are going to have RT equals 4. 4 what? 4 ohms. So we are supposed to find the current supplied. So V equals IR. To make I the subject, you are going to have V on R. So the total voltage here is 24 over resistance is 4. 24 divided by 4. We are going to get 6. So 6 ampere. The next question. A circuit consists of 10 volt battery, a 5 ohm resistor in series, and a parallel combination of a 10 ohm resistor and 20 ohm resistor. Draw a circuit diagram for the setup. So this is a question you need to take step by step. So a circuit consists of 10 volt battery and a 5 ohm resistor in series. So we are just going to take that. So this is your cell or battery and your resistor in series, 5 ohms. Then you have resistors also in parallel. So the first one is 10 ohms. followed by the next one 20 ohms. We are supposed to calculate the total resistance. So we are going to work out the parallel first. 1 over RT equals 1 over 10 plus 1 over 20. It will give us 3 over 20. So 1 over RT equals 3 over 20. Now we cross multiply. So we are going to have 3 RT equals 20. Divide both sides by 3 over 3 over 3. 20 divided by 3. Total resistance for the parallel is 6.67 ohms. Because we have another resistor connected in series, we are going to add 5 to it. So we get 11.67 ohms. So that's our total resistance, 11.67 ohms. Total resistance is 11.67 ohms. Then our potential difference of volts is what it is 10 volts. So V equals I R. So 10 equals so our resistance is 11.67. Then it's the current you are looking for. So divide both sides by 11.67. 11.67 cancels 11.67. So 10 divided by 11.67, you are going to get 0.857 ampere.